like fully is about, we must first get a few definitions and concept correctly in our minds. Okay, first we need to know what is an open system. The definition there, an open system is one that continually interacts with its environment. Okay, like the reaction that we did, the zinc with the hydrochloric acid gives us zinc chloride and hydrogen gas. What happened to that hydrogen gas in our reaction? Just went up into the atmosphere, into the environment. All right. So it is continually interacts with its environment. So in your head you can think of beaker not closed. Or you can think there, gas escapes. Okay? Or another thing that they'll do is they'll say, this is in a beaker, and they take the mass of the beaker the whole time, and the mass changes. Okay? Boki, what's wrong? The? Where? Okay, or they'll say the mass of the beaker is not constant because it has a certain mass and then the gas is allowed to escape. It goes into the atmosphere, so it's not constant. Okay. Then the next concept there is a closed, or we prefer the word isolated system. A closed or an isolated system. That is where the system is isolated from its surroundings. So that is where you have the lid is on, or the mass stays constant, or they collect all the gas. Okay, so nothing is lost. Everything stays in the environment where it is. Yes.
So, say in an exam they give us a table of reactions, different reactions all true, and they write different masses. Then they would ask you, how would you know if there's an open or a closed system and why?
What do you mean with they give you a lot of these different reactions like that?
Different readings of the mass.
Where?
One it's different, one is not different,
Yes. Then they can. Okay. Then up until now we've only done a reaction where there's one arrow pointing to the front. You have this and then you get that. Like for example, you have eggs and flour and now you bake a cake. Can you take that cake and make it back into eggs and flour? No, you can't. Okay? But now we're going to get to reactions where you can go back. And those reactions we call reversible reactions. Okay? So the definition of a reversible reaction is when the products can be converted back into the reactants or reagents. Okay? So one of the reactions that we have is very easy, silly one, is where you have water, solid, and then it changes into water liquid. Obviously, you can take water liquid again and make it into a solid. Okay, so you can see we show that there with two arrows, one pointing forward, one pointing back. You can make it two full arrows as well if you want to, like that. Another reaction, for example, is where you have sodium chloride, solid, and you dissolve it in water, you get the sodium ion and you get the chlorine ion. Then if you take that salt water again and you heat it up a bit, slowly you heat it up and the water evaporates, then it will give you a salt crystals on the side of your container again. Okay, so example of a reversible reaction, but we are going to get to more complicated ones. Right, now before I read there, so if we look at this one here, for example, okay, and so you have a beaker and you have water in it, right, and you heat it up a bit, you make it warm. Where's my flames? You make it warm. Right? Then what's going to happen? The water is going to start to evaporate. Before it even boils, it will evaporate. But what will you see on the sides of the container? You will see that there's little water droplets there. Right? So some of the water will condense again, but most of it will evaporate until everything is gone. Now, if we put a lid on there, all right, then, and you heat it up a bit, then it will evaporate until a certain point where this whole airspace on top of the water is full of water vapor, full of water gas particles. And then it is full. We call that it is saturated. It can't evaporate anymore. Then the particles will be so close together that the intermolecular forces will play a role, and then they'll start to condense again. And as soon as a particle condenses, there's a space open for another particle to evaporate. And then one condenses again, evaporates, condenses, evaporates. And that we call a dynamic phase equilibrium. Dynamic phase equilibrium. Okay, so it says there, if water is allowed to evaporate, so evaporate in a closed system, an equilibrium is established after a time when the vapor formed saturates, when the vapor formed saturates the volume above the water. And then it begins to condense again. For this to happen, the reaction must be reversible. So there on the right hand side, you see water to water vapor, and you can see it goes back and forth and back and forth. Okay, now, if we imagine, I'm going to put this on in a moment again. If we imagine the vapor there at the top, I want you to draw in a few water droplets, your own water droplets there at the top of the water in the closed system. Water droplets, little circles. Yes. At the door. Wie is by die deur? Maritaba. You want to say something to me? Did you report to the office?
No, I will report that to the class.
Okay. You are more than half an hour late to school. Yes, what do you want to ask? Why are you so late, Mama? Are you late every day like this?
No.